Now the same situation for this mean that we did with proportion is when we determine a sample size. Yes, StatCrunch can do it, but I honestly feel like it's easier just to plug it into the formula with your calculator. So we're going to pull that formula out here and work with it. All right. So the sample size required to estimate the population mean with a particular level of confidence within a specified margin, I said that weird, is given by this. N is equal to Z, nope, you did not read that wrong. That's a Z, alpha divided by 2 times the sample standard deviation over the margin of error squared. And then you always round up, right? The same concept applies here. We're always rounding up. Now notice what's happening. That is a Z. Interesting, right? If I'm going to use, even though I'm talking about a mean here, I'm going to use this Z-score because in order to do a mean, I have to have my size of sample. And I have to have degrees of freedom. And I'm talking through all this stuff, right? So we don't need to get that. We don't need to get that information here for this because I can, the bigger it is, and as I make my sample larger and larger that we want to go for here, the Z-score will do it. All right, so the Z-score is what we're going to work with. Okay, so let's do this. We're hanging out with our exact same Toyota Camry, still working there. So how large of a sample is required to estimate the mean miles per gallon within 0.5 miles per gallon with 95% confidence? So how many of these cars, these miles per gallon, am I going to need if I want to go with a margin of error within 0.5 miles per gallon? Now here's my question for you. Does it say the word percentage in there anywhere? No. So whenever I'm seeing margin of error, it's just straight up 0.5. Remember the last section we did an example where it said percentage points. We don't have that word in here. If the word's not in there, you straight up go with whatever your margin of error is. All right. And we want 95% confidence. So if I'm looking at this, I want 95% confidence. That is going to be my Z alpha divided by 2 at 95% confidence. I put our little critical value chart on here. 95% confidence is 1.96. Okay, oops. 1.96. Now the only thing that we don't have for our formula is our sample standard deviation. That we can go to StatCrunch for. The same, just like way back in chapter 3. We did stat, summary stats, columns, and we want var 1, and we only need the standard deviation here. Oops, let me scoot this up. We only need the standard deviation, so we're just going to click on that. And our standard deviation is 2.38. 2.38 is what we're going to use for that. For our sample standard deviation. 2.38. Then we literally plug it in. N is equal to 1.96 times 2.38 over 0.5 squared. Plug that into your handy dandy calculator. And what do you get? I get 87.04. I'm going to go down below because I got this awful close to my standard deviation. All right, so what does it tell me that we're going to do every single time always? Round it up. So how many do we actually need here? 88. Good. We need 88. All right, that's going to be our population. So a sample size of N equals 88 is what we're going for there. Let me change my colors. I was looking to see how I want to write this out. So we need a sample size of N equal 88 results and an interval estimate of the population mean with a margin of error of 0.5. We need a sample size n equals 88 for a margin of error of 0.5 with 95% confidence. Okay, so if we wanted a 0.5 miles per gallon, right? I didn't write miles per gallon in there, I just saw that. 0.5 miles per gallon with 95% confidence. If we want to make sure that that is our margin of error, is just half of a mile per gallon, then we can work with it. Look at this one right here. If we have these values based on this 16, do we have a 0.5 margin of error here? No, we do not, right? That's more than half a mile per gallon for that upper and lower limit to be 95% confident. We need a bigger sample. In order to be 95% confident with only half of a miles per gallon margin of error with 95% confidence, we need a bigger sample. And that's what this is asking. All right? Cool, right? So if I'm talking about mean, I'm using this formula. And then you do need your standard deviation. Sometimes a problem gives you the standard deviation, but if not, no problem. We can go right to StatCrunch in order to pull that off, right? And you know what I just realized up here? We never wrote our steps to StatCrunch. So let's do it right now because I don't want us to miss out on that in our notes. You guys probably already did it because you're amazing. So I'm going to look at this and I'm going to hit Stat, T-Stat, one sample, and then you have to determine if it's with data, which this one was, or summary. And then you just plug all that in. But it is T-stat whenever you're looking at that confidence interval. All right. Man, we are rocking through this semester, and you guys are rocking the socks off of it. I love it.